Next now, I hope this part's okay. The frequency is 5 and the speed is 4 kilometers per second. What's the wavelength? What you guys see, Bob? Correct. Is that okay, folks? 3 marks. So it's nice enough. Right, now let's go on to the harder one, which is a section B question. Now, it's kind of good and bad because it's a full section B question on just waves. But you have to be careful with the English. The string of a musical instrument can be modelled as below. So this is like a guitar or something like this, okay? The string is at a constant tension, blah, blah, blah. The string is plucked, blah, blah, blah. Okay, firstly, what is meant by a node? So how would you describe what a node is? Do you remember the way to describe it? Yeah, what would we say?
Close.
Yeah, we need a bit more than just that. What would you say?
Point where the wave has minimum amplitude.
Yeah, the point in the standing wave of minimum amplitude. Okay. So, what is it for an antinode? It's blah, 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 the same thing. What's the only word that's different in that definition? Yeah, maximum. Well, that's 2 marks. Right, part 3. Right, what do you call the wavelength of lowest frequency? What's that called? The fundamental. The first one, right? So if the length is 75 centimeters, what is the fundamental frequency? So is it open or closed at each end? Is it node or antinode at the ends? Ah, no nodes, because the string is clipped into place. So how much of a wave is in the fundamental case? I think a half. Can you see here, if you look at this, if you were to put a wave here, and it has to be node and node here, the smallest, the first wave would be one that just goes up and down like that. That's half a wavelength. So, if half a wavelength is 75 centimeters, then what's the full wavelength? 1.5 meters. Is that okay, guys? Are you sure? Are you just confused or tired or both? Matt? Confused? Not confused? Okay. Siva? Yes? Continue. If the frequency is 800, what's the speed of sound? Okay, so what formula do we use there? To get speed of a wave? And what's the F? And what's the lambda? I thought we said it was 1.5. Didn't we? Yeah. So the speed here of the wave on the string is the wave is moving quite fast. Well, you kind of know this when you pluck a guitar string, it moves so fast, you know. It's 12,1200 meters per second. Yeah. Sorry, I said it's the speed of sound. It's not the speed of sound, it's just the speed of the wave. Guys, I'm not going too fast. Is that all okay? Right, the next one. What is the frequency of the second harmonic? Okay, let's be super careful. So, how, in the fundamental wave, how much of the wave fits into between the two bridges? Half. So for the second harmonic, how much of the wave is it that fits in? One full wave. One full wave. Okay? Now, the string is 75 centimeters long. So what is the wavelength for the second harmonic? Well, it's also 75 centimeters, because this one's nice and clear. The second harmonic is one full wavelength inside the two bridges. So the wavelength is equal to the length, which is 75 here. And what do we want? We want the frequency. So the frequency equals the speed over the wavelength. So tell me what you get. It's the same speed as before. 1600. Is it? Okay. Do you have this one? What's the frequency? See that?
Yeah.
Did you get the frequency?
I got 16.
Just 16. What did you type in to get just 16?
1,275.
0.75. It's 75 centimeters. Yeah, okay, that makes sense now. What did you get, Matt?
1600.
That does better. Okay. Right, the next part. Guys, is it okay so far? Do you have any questions?
Maybe a little bit slow.
Yeah, it's fine. Yeah. Okay. A third bridge is added in order to produce a node 25 meters from the end of the, 25 centimeters from the end of the string. So you put another bridge about here. Can you see? And the reason you do that is to make a node here. So you have a node here, a node here, and a node here. Yeah? And the question is to sketch what the fundamental wave would look like. So I need you to draw the biggest wave that you can that will have a node here, here, and here. The distance here to here is 50, and here to here is 25 centimeters. Okay? Now I'll give you just a minute to draw that, then I'll put it up on the screen, and you can see if it matches. Right. This is what it looks like. So here to here must be half a wavelength between the node and the node. Now half a wavelength is the 25 centimeters. So if half a wavelength is 25 centimeters, then for 50 centimeters you must have a full wavelength. So in total you'll have 1.5 waves between the two ends. Does that make sense for you guys? Continue? Yeah? Yeah? Okay. So for the next part you have a different string of 75 centimeters and it has a frequency, a fundamental frequency which is the same as the answer from part 5. What was our answer for part 5? What was our answer for part 5, the frequency? 1600. Okay. So we want now to calculate the speed. Okay, so what's the formula for speed? V equals F lambda. Now what did you say? Sorry, Steve, I know you just told me what? 1600 lambda. Okay, now, what is the wavelength? Well, how much of a wave do we get in the fundamental case? How much fits in here of a wave? Half. Yeah? So if half the wave fits in here, and that's 75 centimeters, again, what's the length of a full wave? See, it's very similar. So it's 1600 times 1.5. So what do you get as the answer? Meters per second. For another 2 marks. Yeah? Finally, for part A, is it transverse or longitudinal, the string wave? I think it's transverse. Because when you think about a string and you pluck it, it's going up and down like this. So it's transverse, and the reason it's transverse is because it vibrates perpendicular to the string. Oh my goodness, they stole my question. Not that they haven't my workbook, but the B part question is the same question I made up in the book about walking between the two speakers. So, you have a frequency of 1500 is produced between two speakers which are 1 meter apart. Oh, that's even the same number I used, wasn't it? 1 meter apart. An interference pattern is produced. And the speed of sound is 330 here. An observer moves along. So this is exactly like the one I did in class. The guy, he's walking along and he hears the interference pattern from the two speakers. He moves along and 20 meters from the sound and he hears it getting louder and quieter. What's the distance between the two loud spots? So that's the fringe distance. What's the formula for the fringe distance? What letter did I call that? S, wasn't it? Or X? I don't remember. S. So S equals lambda D over D. Can you calculate the S? It's lambda D over D. And the speed of sound, you'll need to use it as 330. 4.4? Is that what you said, Matt? Correct. 4.4. Okay, part 2. Did you get 4.4, Siva? Can you tell me what you used in your fraction? So you said S equals, so what numbers did you have on the top and the bottom? What are you calculating now? Ah, okay, I see, alright, yeah. Do you want to see the answer, or do you think you'll get to it? Matt, what did you get for lambda?
330 over 1500.
Yeah, which is
0.22.
good, okay. Yeah. So in your formula, lambda is 0.22. What's the value of big D here?
20.
Good. And small d?
1.
1, good. So you put that in and you get out 4.4 is the answer. Yep, okay. Part 2. What happens if the speakers are separated an extra half a meter? So which changes in your formula? Lambda, big D, or small d? If the effect of the loud spots, what happens if the speakers are moved to 0.5 meters apart? So instead of being something apart, they're 0.5. And what's changing here? The big D, the small d, the lambda? The small d, instead of being 1 meter separated, they're half a meter separated. So what is the change in the fringe separation if you change your 1 meter to half a meter? Yeah, what would it be exactly? If you recalculate it, you'll get 8.8 meters. Because in your formula, you divided by 1. Yeah, you had a 1 down below. But now you're dividing by 0.5. So you'll get 8.8. Is that what you got, Siva? Yeah. Part 3. Final part. The speakers are still half a meter apart. Determine what frequency you would need to get back to the original fringe separation. Okay, so let's write the information down here. What fringe separation do you want? You want it to be back to 4.4. Yep. What is the big D? The big D is still 20. The small d is still 0.5. And now this time the speed of sound is still 330. But the frequency you don't know. Okay? So I want you to calculate the frequency. So I'll repeat the information. S is 4.4. Big D is 20. Small d is 0.5. V is 330. What must the F be? I'm calculating it by pen and paper here. 2. This is much harder without a calculator. I got somewhere around about 3,000. What is it exactly? Oh yeah, sorry, 11 goes into 11 once, 11 goes into that 3 times. Exactly 3,000 hertz. So that's 3 kilohertz. Yeah? Now, by the way, as I was working it out myself at the same time you were, I was recording. So if you wanted to actually see what I wrote down, you can. I got the same answers as you guys. Before we go, let's check the marking scheme. Make sure we got everything right, okay? Let's open this up here. What question was this? Let's see, where is it? Okay. What is a node? A point on the stationary wave where there is virtually no displacement, so minimum amplitude. A point on the stationary wave where there's maximum amplitude, that's the antinode. Yeah? Did we get 1.5 here? We did. Did we get 1200 here? I think we did. Did we get 1600 hertz for the next one? Okay. They don't have the picture. It's a sine wave, 3 antinodes. Yeah, okay, that's fine. Right, next part was the frequency 20 or the speed 2400. It was, okay. Transverse and vibration is perpendicular. 4.4, 8.8, and 3000. Yeah. I don't know. What do you think about the wave question? Good, bad? What?
The sketch.
Sketching is bad, huh? But the rest? Oh yeah, you don't like graphs in the exam. I remember.
I don't understand.
Yeah. Everybody's wondering who got the highest maths results. That might be you, is it? Do you have any competition in business class?
Joseph got 99.
Ooh, 99. I would not stand for that. What's Joseph's story? Where's he from? Malaysia. He got 99. And he's in business class? He should be an engineer. He should be with us.
He was in science stream.
He was in science.
In high school.
Ah. So why did he all of a sudden change the business? Family decision?
I don't know.
99. 99. And he's studying business. What a waste.
Maybe he's studying finance.
Well, that's true. Perhaps he wants to go to become an actuary or financial advisor or something like this. Okay. Right, so I think what we'll do next time, I think we'll do one more lesson or two more lessons on just wave exam questions. Well, maybe we'll do another one or two of them, and then we'll go on to the next chapter. Okay? Okie dokie. So where's Kim?
He said she's coming to math. She's going to be like,
And she lives on campus. That is disgraceful. If you're watching Kim, that's disgraceful.